Hey everybody, hope you're doing well. This week's lesson is about our moon, Luna, and we'll talk about moon phases a little bit and solar and lunar eclipses. So you should have read pages 129 to 136. We'll look at them together a little bit here. So we all know that Earth revolves around the sun. And it takes about a year for it to do that. It's 365 and a quarter days. And then our little moon over here revolves around the Earth, uh, like so. And it takes the moon about 27 days, 27, 28. It's about a month. So we have a lunar month where we have, you know, a new moon goes through all the phases to a full moon and then back to new moon. We'll talk about those phases and why we see different parts of the moon lit up. Our moon is held in orbit by gravity. And so here's what happens. We only ever see the same side of the Earth, or I'm sorry, of the moon from Earth. Because if this is Earth right here, and let's say my palm is one side of the moon. So if it takes 28 days, and now you guys are seeing the back of my palm because you're out in outer space right now. But if you were on Earth, you would only be seeing my palm right now. Imagine you're like sitting on my hand here, which I know obviously can't happen, but here's what happens. As the moon is revolving, it's also rotating. Do you notice how right now you see my palm? From Earth, they see my palm. And then as it's going around, they're still only seeing my palm. If you're here on Earth, palm, 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 palm. Now, obviously I can't do this, but still palm, because as the Earth was revolving, it's also rotating. It takes the same amount of time for it to rotate as it does to revolve. Think about if this is the sun now, and this is Earth, Earth actually revolves pretty quickly. It takes 24 hours. That's why we have day and night. But the moon revolves slowly. It takes the same amount of time. So the rotation and revolution period are the same. All right, so now here on pages 132 and 133, you can see this big diagram of all the moon phases. I want you to notice though, so the Earth is in the center, the moon is revolving around the Earth. If you notice, in each little picture of the moon, half of it is lit up. You can see here that if let's use this to show that it's lit up. The sun must be out here. Half is lit. Half is lit. Half of it's lit up here. Half of it's lit up here. And here, and here, and here, and here. So the same half is always lit up. But we're not in outer space looking at the moon. We are here. And we're looking out. So let me use a different color here. If we are looking out at the moon, so in new moon phase, when it basically looks like the moon is all dark, we're looking out here. This is our view. If this is out in space and this half is lit up because the sun's out here, when we look out, we're going to see darkness. And sometimes you can see like a little outline, but it's not lit up. And remember, our moon doesn't give off its own light. It's basically just a rock out in space, and it reflects the light from the sun. So in new moon phase, when you look at the moon, you don't see any of it. Now, as our moon goes from being completely dark, like the view that we see from Earth, when it's getting brighter and almost all the way, and then becomes a full moon, we call that waxing. So waxing, think about if you wax a car, when you wax the car, wax on, wax off. When you wax on, you're making it shinier, right? You're not going to say like, I'm going to go wax my car today because I really want it to be dull. You want it to be brighter. So you would waxing makes it shinier. So waxing with the moon is when the lit up portion is getting larger. It's getting shinier. So going on from new moon, where we don't see any of it, we then go to waxing crescent. So from here, if I try to erase this little mess here that I made, if I were looking up into the sky now, I would see just this little sliver on the right side. Imagine you're here looking up and you see just a fingernail. That would be your waxing crescent. Then our next position, you would look up and it would look like half of it's lit up, but you're really just seeing that quarter because you don't see the other side of it. That's first quarter. Going on as it's getting shinier, when it's not quite a full circle, but almost, and this little dark part is left behind, that's called a gibbous shape. So waxing gibbous is when it's going towards full moon. So we have our waxing gibbous. And then here we would look out at our moon and it would look like the entire thing is lit up. But again, remember, only half of it is lit up. If you look at these little views, half is always lit, but the portion that we see changes. So now we've gone from new waxing, getting shinier and shinier until it's full. Can't get any shinier. Then we start the waning phases. Waning is when it's getting smaller. So we had a full moon. Now from this position, if we looked out, let's go ahead and use, I don't know, pink. If we were to look out at the moon from here, we would see the shiny part. Like you have to imagine you're looking at it like this. Imagine if you're here on Earth looking out, the shiny part would be on the left now. So this is your waning gibbous, and you have your dark part here, waning gibbous. And then it takes us to third quarter because you would look out. If you're here looking out, this would be your left. Imagine you're on the Earth, you're sitting on there looking out. So the left side would be shiny. It would look like half of it. This would be third quarter. Sometimes they call it last quarter. If you ever see last quarter, it just means the same thing. It's the same as your third quarter. And then we go back to our little thumbnail, but this time it's on the right. I'm sorry, just kidding. It's on the left because remember, you're looking out. I'm looking at it this way and I would see just this little crescent here. That's your waning crescent. And then you go back to new moon and that takes about a month. The lunar phase is about 1 calendar month. Okay, so now we're going to talk about eclipses. And you might think that there would be an eclipse every time there's a full moon or a new moon because you look at it and you're like, well, if the sun is over here, these are the sun's rays, and if they're shining this way and the moon is behind the earth, don't we always get a shadow? We don't get a shadow every month. Otherwise, we would have an eclipse every month and it wouldn't be such a big deal. I don't know if you remember in class, most of us did, we talked about this a little bit and mentioned that we don't have eclipses every month because if you do this, remember if you put your thumb, like right now, I'm blocking out my face on the camera. But if you notice, I had to move it exactly right. Now, if I were right next to it, I could eclipse it. But if I'm far away, in order to eclipse it, I have to get it just right. So if you do that to something in your room, like right now, my dog is laying on the couch and I can cover her face just right and create an eclipse if I move my thumb just the right way. So our moon's orbit is tilted. It's not exactly straight like this. It's tilted 5 degrees. It's a very small tilt, but that means in order to create that shadow, it's got to be just right. It doesn't happen on a certain cycle. It doesn't happen on a certain schedule. But scientists can figure out when it's going to happen. That's how we knew our big solar eclipse was going to happen a few years back in the fall, if you remember that. Some of you may have gone and traveled somewhere to see it in its entirety, because we were not in the full eclipse. We were in a partial eclipse here in our area. But here's what happens. I want you to know the parts here. And these terms are on your Quizlet. So let me put the mouse back on, move this away. If we are looking here at number 11 on page 134, it shows you the parts of an eclipse. And it says during a lunar eclipse, the shadow of Earth falls on the moon. So you've got sun, Earth, moon. Now, what phase would this be? What moon phase? If the sun is here, Earth, and this side of the moon is lit up. Anybody? You're right. Are you right? Did you say full moon? If you said full moon, you're correct, because this side's completely lit up. Now, a lunar eclipse happens during a full moon, so you can see it at night, and your moon would look kind of orangey. So here are the parts. The full shadow is called an umbra. So you can see this like dark, full shadow, the umbra. And I always remember like full shadow, full cover, like an umbrella. And then the partial umbra, the penumbra, it like spreads out more. So you can see here the penumbra. So a lunar eclipse during a full moon. Let's go ahead and talk about a solar eclipse. How do I get these little tools back? Okay, here we are. Page, what page is this? Page 135, talking about solar eclipses. So now a solar eclipse happens during a new moon. And I always remember this because if you're going to see a lunar eclipse, you're going to see the moon. So you would see it full. A solar eclipse happens during new moon. You see solar eclipses during the day because the sun has to be shining. So a solar eclipse happens when there's a new moon, or that's just how I remember it, because you have, so if our sun's over here, sun's rays, moon, earth. So from the earth, if the sun's over here, the side that I'm going to see is going to be dark, new moon. Now, what happens here is the moon perfectly eclipses the sun. It perfectly kind of like blocks it out. If you did go see that solar eclipse in full eclipse, you saw it went completely dark. It might have slowly been covering and covering and covering, and you might have felt it getting darker. Maybe, I know we talked about in one of my classes, crickets started chirping. It got a little bit cooler, and this was in Johns Creek. So any of you who went and saw it in totality, wherever, like if you traveled to maybe North Georgia or Tennessee, South Carolina, anywhere that full eclipse line fell, you might have seen the full eclipse. So a full eclipse does not happen on the entire Earth. You have to be in the line of the eclipse, because if you see, this is a very tiny little umbra. The full shadow is small. Anywhere that we saw the partial eclipse, we were in the penumbra, which is quite a bit wider. So those are our solar